The periodic table provides a lot of information. The elements are arranged according to atomic number, which is represented at the very top of each box. And the atomic number tells us how many protons are in that atom. So whenever we see an atom that has 6 protons, we know that it must be a carbon atom. If we see an element that has 82 protons in its nucleus, it must be a lead atom. We also notice that the elements are arranged in vertical groups, which share similar properties. For example, this second last vertical group here are called the halogens. They all share very similar chemical properties in that they will form -1 ions. The final group here is known as the noble gases. They tend not to react with other elements. Another piece of information you can get from the periodic table is the very small number there beneath each element. For example, this 19.00 beneath fluorine. Now that 19.00 means that if you have 1 mole of fluorine atoms, it has a mass of 19 grams. Now, what does 1 mole mean? It means if you've got 6.02 times 10 to the 23 particles. That particular number, 6.02 times 10 to the 23, is called Avogadro's number after the scientist who first determined it. What he determined is that if you had Avogadro's number of hydrogen atoms, it was 1 gram, or he said how many atoms are in 1 gram of hydrogen. Okay, so if we look at things, for example, carbon has a molar mass of 12.01, that's 1 mole of carbon atoms has a mass of 12.01 grams. 1 mole of oxygen atoms has a molar mass of 16 grams. So imagine you had 32 grams of oxygen atoms. Now we know that 16 grams represents the mass of 1 mole of oxygen atoms. So how many moles would 32 grams represent? I think it's pretty obvious that 32 grams of oxygen atoms would represent 2 moles of oxygen atoms. Now we've done that because the numbers are very easy. Let's have a look at a mathematical relationship now, which will allow us to determine how many moles there are in any mass of any element sample that we look at. Now what we actually did in the previous example is we knew that the actual mass of oxygen was 32 grams, and we knew that the molar mass of oxygen was 16 grams. So what we did is we said 32 divided by 16 would give us the number of moles, and 32 divided by 16 is 2 moles. Now, I've done that without any real equation there. What we do is use this equation. The equation is number of moles is equivalent to the actual mass divided by the mole mass. And we can actually use symbols to make this equation simpler to write. And the symbols we use are a lowercase n represents the number of moles, a lowercase m represents the actual mass, and an uppercase M represents the molar mass. What I'd like you to do now is to use this equation to solve the problems on the next worksheet.